Okay, look at this figure. Yeah, to illustrate table 13.7. Yes, so the horizontal axis is the number of stock in the portfolio, and the vertical axis is the overall risk of the portfolio. So when we increase the number of the stock in the portfolio, we can decrease the risk of that portfolio. But you see, at a certain level, we cannot diversify more. I mean, we cannot reduce at there's a certain level of risk that whatever the stock you include in your stock in your portfolio, that risk is stay there. Yeah, it did not diversify away. So we call this kind of risk is systematic risk, and this amount of risk is diversifiable risk or unsystematic risk. Yeah. Okay, and look at this difference between systematic risk and unsystematic risk. Yeah, systematic risk, basically that is the risk factors that affect a large number of assets. For example, GDP recession. Economy recession, economic recession. Yeah, so when that happened, most of sector and the company in the economy, in that economy will be affected. Yeah, but for example, one risk happened to a certain company, will affect only that company or related company or that sector, while the other sector or the companies stay unaffected. For example, what happened to Novaland is failed to meet the application to pay back the principal and the coupon of the bond. Yeah, so when that was happened, it affects Novaland and the related company like the related banks and security company that related to that bond issuance. Yeah, but not affected the whole system. Okay. So we call that one a kind of unsystematic risk. Yeah. So, and notice that there is a reward for bearing risk, but they're not a reward for bearing risk unnecessarily. So what kind of risk is unnecessarily? Yeah. Okay, so you see there are two kinds of risk, unsystematic risk and systematic risk. Yeah, and this figure illustrates that by diversifying, you can eliminate the diversifiable risk, or you can eliminate the unsystematic risk. So that risk should not be there, right? So that is the unnecessary risk, the unsystematic risk here, because you can diversify away. And if that risk is still in your portfolio, that is your fault. Yeah, because it's not necessary to be there. So there will not reward for bearing unnecessary risk. Yeah, and only the reward to bearing the necessary risk. That is the systematic risk. Okay, bear that in mind. So the expected return, okay, on a risky assets depend only on that asset's systematic risk. Why? Because unsystematic risk can be diversified away. Okay, so from now on, bear this in mind. Expected return is only for a systematic risk. Yeah, so the reward to risk, the return is only for systematic risk. There are no reward for bearing unsystematic risk. Okay, bear that in mind. So if we keep that in mind, now I divided total risk, yeah, based on by systematic risk and unsystematic risk. And because unsystematic risk can be diversified away, so it's equal to 0. And consequently, the total risk for diversified portfolio is essentially equivalent to the systematic risk only. Yeah. So the total risk is the standard deviation. Yeah. And we measure systematic risk by using one coefficient we call beta coefficient. That's it, we had to agree on. Okay, so this is what we agree. A beta of 1 implies that the assets have the same systematic risk at the overall market. Quy ước như vậy nha các bạn. The beta of M of the market is 1. So if an asset, for example, a stock, had a systematic risk, had a beta, the same systematic risk with the overall market. So that stock have beta of 1. The same with the market. And if that stock had a beta smaller than 1, that means the asset had less systematic risk than the overall market. Yeah. For example, if you check Vinamilk, it has beta smaller than 1. So Vinamilk had less systematic risk than the overall market. Yeah. And if you check another company, I don't know, for example, Huafeng, it has the beta greater than 1. That implies that stock had more systematic risk than the overall market. Okay, so please check for the company of your choice. Okay, let's work on one example to see the difference between systematic risk and the total risk. We have security C and K, and this is the total risk, and this is the systematic risk, beta. So security has C had lower total risk but higher beta. Yeah. So with security had more total risk, we look at standard deviation. Yeah. So that is security K. And with security had more systematic risk, we look at beta. So that is security C. And now is the tricky question. Which securities should have the higher expected return? C or K? Yeah, remember, return is the award, the reward for bearing risk. Yeah, and only bearing the unsystematic risk. Sorry, only bearing the systematic risk. Yeah, so C had higher systematic risk, so C should have higher expected return. Okay, yeah. So now consider we calculate the portfolio beta. So if we have a portfolio of different assets, so how we calculate the beta of that portfolio? So the same principle when we calculate the expected return, we have the weight of each security in our portfolio and the beta, and we take the weighted average. Yeah. Weighted average, you take the weight, multiply for the beta of each security, and then you add them together and you had the portfolio beta. Okay? So now beta measure systematic risk. Yeah? At the higher risk, the higher return. Okay? So can we define the relationship between the risk premium and the beta so that we can estimate the expected return? The answer is yes. So look at this example, the following example. Okay, consider a portfolio made up of assets A and the risk-free asset. Yeah, this is our portfolio. We have assets A, and we have the risk-free assets. And asset A, with the expected return of asset A is 20%. Yeah. And the beta of asset A is 1.6. And for the risk-free rate, the expected return of risk-free rate is exactly that risk-free rate. Okay, we don't write expected return. Well, yeah, I write like this, but to let you know that expected return of the risk-free rate is exactly is risk-free rate. Yeah, 8%. Okay, so when we allocate the percentage in portfolio in assets A from 0 to 150%, we come up with this table. Yeah, so this is WA, and of course, when you know WA, you know W in risk-free asset. Yeah, and this is expected return of the portfolio, and this is the portfolio beta. And now I want to see, and I want to graphical illustrate the relationship between portfolio expected return and the portfolio beta. Okay, look at this figure. Okay, this point, the horizontal axis is the beta of the portfolio, and the vertical axis is the expected return of the portfolio. Yeah, and at this point, this is you invest in 100% in risk-free asset. Yeah, so the expected return of the portfolio is only come from risk-free assets because you invest 100% in that asset. Yeah, it's 8%. And of course, at that point, the risk of the portfolio is 0. Yeah, and this point is 100%. You invest in A. Or in other words, WA is 100%. Yeah. This one WF is 100% or 1. Yeah. Okay, so I only need to point you draft a line to illustrate how your portfolio return look like for given level for different allocation between A and the risk-free asset. Yeah. For example, if you are here, yeah. For example, the midpoint between risk-free assets and A. Yeah, at that midpoint, you invest 50% in A and 50% in risk-free assets, and the beta is okay. The beta is 0.8. Yeah, beta is 8. 0.8, and the expected return is 40%. Yeah, 40%. 14%. Yeah. So you see, the higher the beta when you go further to the east. Yeah. The higher the beta, the higher expected return of the portfolio is, right? So I will let you know that for 1 unit increase in beta, how much return I earn. Or in other words, I will let you know for 1 additional unit of risk, beta is risk, yeah, how much is my reward? Yeah. So that is the question of the reward to risk ratio. Yeah. And that is, and the answer is the slope of this line. Yeah, the slope of this line, this one. It measures the higher, the bigger the slope. For example, the slope is bigger. Yeah. So I mean, for the same level of beta, yeah, you have higher expected return, much higher expected return, somewhere like this, right? And this slope is much bigger than this slope, right? So to find the reward to risk ratio, that define the slope of this line. Yeah. Okay, so the slope of this line is calculated as follows. So this is the slope, yeah, is equal to this, yeah, distance, this distance plus, and this distance divided for this distance, yeah. Okay, so this is expectation of access A, subtract for the distance F, and divided for the beta of asset A. Yeah, this is the slope, and we calculate this is 7.5%. What does that mean? 7.5% means asset A has a risk premium of 7.5% per unit of systematic risk. Yeah. Okay. What if an asset had a reward to risk ratio of 8? Yeah. So basically, this is the line. Yeah, A. For example, this. For example, this is asset B. And this is the slope. This is 8%. What happened? Okay, if they're in the market, there are assets B and with the slope of 8% and asset A with the slope of 7.5%, what will we do? We will buy assets B, right? Because it offers higher reward ratio, and sell assets A. Yeah, because it offers lower reward ratio, right? And when you sell assets A, you make the price of A decrease. Yeah, and of course, therefore, the expected return of A will increase. Look at remember in chapter 2 on the content of time value of money and the stock valuation. When the price go up, the expected return goes down. Yeah, and vice. And for assets B, when we buy assets B, we drive the price of B up, and the expected return of B goes down. And when we will stop? When they meet each other at some point, at one point, right? And for example, if there's a market in a market, there another asset has reward ratio of 7, mean it's smaller than this. For example, there's another asset had this. So lower, yeah, lower slope, lower risk reward, reward ratio. So what? We sell that asset. For example, this asset C, we sell it, right? And we drive the markets down and expect the return of C goes up, right? And when we will stop doing so? When A, B, C meet each other at one point, when they are conjugate. Yeah? And at that point, we call equilibrium. At equilibrium, all assets and portfolios would have the same reward ratio. Yeah, with the arbitrage, mean sell and buy, arbitrage sell and buy. So all the assets will conjugate, will meet at one point that we call that one equilibrium, and that is the market. Yeah, and but equal to the reward ratio of the market. Yeah, market I say M is the market, and this is the reward ratio of the market. And remember, beta M is equal to 1. Yeah, so the slope, this is the reward ratio of the market. Yeah, and because beta is 1, so the slope of the risk reward ratio of the market is only this. Yeah, and you see, this is actually the risk premium, and because it is the market, so we call market risk premium, and that is the slope of the market line, the security market line. Look at this figure 11.3. Yeah, so now all the assets will, we see we meet each other at one point, that is equilibrium point. Yeah, so this is the green line that we call the security market line. Yeah, and the equation that describes the security market line can be rewritten as this. Yeah, okay. And we call this one a capital assets pricing model. That's how we name it. Okay. So for any given assets, for example, you check with Vinamilk, the beta of Vinamilk is somewhere like beta 0.9. Yeah, and you move on this. So you have the expected return of, this is the expected return of stock I. Yeah, beta I equal to 0.9. Yeah, and if a stock had higher beta, for example, the beta can be somewhere here. Beta is 1, beta of stock J is 1.5. Then this is expected return. It should be, yeah, should be expected return of stock J. So depend on the beta of the stock, the expected return will be determined by the beta of that stock and the slope of this line, and remember the slope of this line is this. Yeah? Okay, it's divided by for beta m, but beta m is 1. So basically we still have this. Okay, for example, this is the refrigerate, 54%, market risk premium. So the expected return of assets, for example, assets I, yeah, equal to F plus beta. Yeah. The beta. For each asset, for example, here we have one example here. The beta for, yeah, DCLK 26. Okay, and the market risk premium is 0.5%. Okay, so you can calculate expected return of the stock, this stock. Sorry, erase ink. Yeah, here. Okay, and for example, the comprehensive problem, the reference rate 4%, required return on market. So this is RF, required return on the market. So this is expected RM. Remember, the risk market premium, that's the difference between the return on the market and the reference rate. But here we have only return on the market, so that is only expected return on the market. And this is the beta. So the expected return of assets I is 4% plus, yeah, and please come up with the result yourself. What if